Did you know your stomach acid is as strong as the vultures? That's not an accident. It's proof humans evolved to eat meat, and you've been told to eat more plants. Your biology might actually be fighting against it. Let's break this down. Hey everyone, my name is Mark Bates. I'm a metabolic health coach, and this video is on your stomach proves humans are carnivores, the evolutionary case against plant-based diets. So let's break this down in here. One, your stomach reveals humanity's carnivorous past. Yeah, the human stomach produces acid so corrosive it could dissolve a razor blade. At pH 1.5, human gastric acid matches the digestive power of vultures and hyenas. This isn't a coincidence, it's evolutionary evidence. Most people assume humans evolved as omnivores, equally adapt to plants and meat. The biological evidence suggests otherwise. From stomach acidity to shoulder anatomy, human physiology bears the unmistakable signature of a species designed for meat consumption. The implications extend far beyond dietary preferences. Modern humans following plant based guidelines may be fighting their own biology, creating a cascade of metabolic dysfunction that reaches from individual cells to entire populations. So let's talk about your stomach here. Human stomach acidity sits at the extreme end of the digestive spectrum, while omnivores, like pigs, maintain stomach pH around 3 to 4, right? Herbivores, like elephants, hover near a pH of a 6 to 7. Remember, the higher the number, the less acidic, right? Humans produce gastric acid comparable to carrion eating species, about 1.5. The extreme acidity serves a specific purpose. Scavenged meat carries high bacterial loads that would sicken or kill animals with less acidic stomachs. So the purpose of the highly acidic stomach is to kill all the extra bacteria. Think about probiotics that you pay a lot of money for. The evolutionary pressure was clear. Early humans who could safely digest partially decomposed meat gained access to calorie dense nutrition unavailable to competitors. Those with weaker stomach acid didn't survive to reproduce. But this carnivore level acidity creates problems when processing plant compounds. Lectins, tannins, and other plant defense molecules will often survive the acidic environment, reaching the intestines where they can bind to gut walls and trigger inflammation. Herbivores evolved specialized systems to neutralize these compounds. Humans did not. So, your digestive architecture problem. Human intestinal structure tells the same story. The small intestine, where nutrient absorption occurs, comprises 67 to 80% of total intestinal length. The large intestine, specialized for fermenting plant fiber, makes up just 20 to 33%. Compare this to gorillas, for example, where the large intestine dominates at 77% of total length. Gorillas can extract up to 60% of their energy from fiber fermentation. Humans can barely manage 7%. This architectural difference has profound implications for modern dietary recommendations. High fiber diets may actually increase digestive stress in humans, promoting bacterial overgrowth and endotoxin production. When fiber fermenting bacteria proliferate, they generate lipopolysaccharides that can cross into the bloodstream with dietary fats. The result is systematic inflammation masquerading as healthy eating. People transitioning from high fiber to meat based diets often report dramatic reductions in bloating, gas, and digestive discomfort. Their gut microbiome shifts from fiber fermenting species to protein and fat metabolism bacteria better aligned with human physiology. Then you've just got a basic thing here. People always ask, well, how did we take down game? Well, humans have a very unique anatomy, okay? We have what's called the throwing revolution. The strongest evidence for human carnivory lies not in the gut, but in the shoulders. Humans possess unique anatomical adaptations for throwing projectiles with lethal accuracy and speed. Right? An 8-year-old child can throw a baseball at 40 miles per hour. Adult male chimpanzees supposedly our closest relatives, only manage about 20 miles per hour with their best overhand throws. Elite human pitchers approach 105 miles per hour. This throwing ability required specific evolutionary changes: expansion of the waist, lowering and repositioning of the shoulders, and the emergence of low humeral torsion all appeared together approximately 2 million years ago, give or take, right? In Homo erectus, right? So remember, that ability to throw is not something anyone else has in the animal world other than humans. The timing coincides perfectly with archaeological evidence of intensified hunting activity. Success at hunting allowed early humans to become part-time carnivores, accessing calorie-rich meat and fat that dramatically improved fat diet quality. This dietary shift enabled larger bodies, larger brains, and increased reproductive success. The throwing shoulder didn't just make humans better hunters, it made them human, right? Small canine teeth, often cited as evidence against human carnivory, actually support this technological hunting hypothesis. Humans didn't need large teeth for killing, they had spears. Okay? The nutrient absorption crisis. Modern plant based diets create a perfect storm of nutrient challenges. Anti nutrients in legumes, grains, and vegetables actively interfere with mineral absorption. Phytates bind iron, zinc, magnesium, and calcium. Oxalates form crystals that irritate tissues and block calcium absorption. Lectins damage intestinal walls and trigger autoimmune responses. These compounds serve as plant defense mechanisms, evolved to discourage consumption. Herbivores developed specialized gut bacteria and extended fermentation chambers to neutralize these toxins. Humans rely on cooking, processing, and careful preparation. Even with these interventions, bioavailability remains poor. Iron from spinach absorbs at roughly 2%, compared to 15 to 25% from meat sources. The human digestive system simply wasn't designed to extract nutrients from defended plant tissues. Essential nutrients like vitamin B12, DHA, creatine, carnitine, and taurine exist primarily or exclusively in animal foods. Restricting these nutrients forces the body into suboptimal metabolic states, potentially impacting everything from cognitive function to cardiovascular health. Okay? So, what we actually have is a species level experiment for the last, let's call it 10,000 years. The widespread adoption of plant based diets represents an unintentional experiment on human biology. For the first time in evolutionary history, large populations are restricting the nutrient dense animal foods that fueled human brain development. The consequences may extend beyond individual health. Chronic nutrient deficiencies can trigger epigenetic changes that persist across generations. Children born to nutrient depleted parents may inherit compromised metabolic and cognitive baselines. Yes. Studies of famine populations reveal how quickly nutritional trauma becomes heritable. The Dutch hunger winter and Chinese Great Leap Forward famines created lasting epigenetic changes in offspring, increasing risks of metabolic disorders and mental health conditions decades later. Modern Western diets may be creating similar damage through a different mechanism. Instead of acute starvation, chronic micronutrient deficiencies create slow motion cellular famine despite caloric abundance. The body prioritizes immediate survival functions over long term maintenance when nutrients are scarce. DNA repair, cellular maintenance, and antioxidant defenses get shortchanged. This triage response accelerates aging and increases chronic disease risk. So, speaking of which, let's rethink human aging. The implications reach beyond diet into fundamental questions about human lifespan. Modern aging may represent accelerated malnutrition damage rather than inevitable biological decline. Ancestral humans likely experienced slower intrinsic aging despite shorter lifespans due to external threats. They had access to nutrient dense foods that supported cellular maintenance and repair systems. Modern humans live longer due to medical advances, but suffer shorter health spans due to chronic metabolic dysfunction. The diseases we associate with aging may actually represent the cumulative effects of nutritional inadequacy, right? You're not feeding your body properly. This reframing suggests enormous potential for extending human health span. By realigning diets with evolutionary biology, individuals might routinely maintain cognitive function, physical capacity, and metabolic health well beyond current expectations. We're not talking about just living longer, but living like in a retirement home, sitting in a wheelchair. We're talking about living longer vibrantly, okay? There's no reason why not. There are archaeologists find these ancient tribes that are living in the jungle where there are 80, 90-year-old people running around hunting and fishing and doing all the stuff everyone else is doing, and they don't look anywhere close to that age compared to Western people. Okay? It's not feeding your body properly. Okay? So the question isn't whether humans can live longer, but whether they can restore the biological foundation for optimal aging that their ancestors possessed. So is there a path forward? Yes. Course correction requires acknowledging the evolutionary mismatch between human biology and modern dietary recommendations. This means prioritizing nutrient-dense animal foods that provide bioavailable vitamins, minerals, and essential fatty acids. Such diets support improved insulin sensitivity, reduced inflammation, and restored gut barrier integrity. Cognitive function benefits from adequate DHA, B vitamins, and other brain essential nutrients, often lacking in plant-based approaches. The transition isn't just individual. Population-level dietary shifts require changes in public health guidelines, food production policies, and agricultural practices. Early intervention, especially in maternal and childhood nutrition, becomes critical to prevent transgenerational transmission of metabolic dysfunction. Some damage from prolonged nutrient deficiencies may prove irreversible, particularly in advanced neurodegenerative conditions. However, the human capacity for metabolic recovery suggests significant potential for improvement with proper nutritional intervention. Yeah, you may not ever get back to 100% where you should be, but you can get really close. Okay, the species level experiment continues today. Right, that's the human species level experiment. But the biological evidence points toward a clear conclusion. Right, just look around you. The vast majority of humans on this planet are metabolically unhealthy. They're overweight. They have diseases of aging and chronic disease, right? We've fixed a lot of the diseases caused by bacteria and viruses, but we've killed ourselves with what we're eating. Okay, it's quite simple. Okay, the stomach acid that could dissolve metal tells a story about human origins. So listen to it. It's time to listen to what our biology has been trying to tell us. All right, everyone. Hey, thanks for watching. If you have any comments or questions, leave them in the appropriate section. This is a community. We're here to try to answer your questions. So if there's something you want me to cover in an upcoming video, let me know, and we'll get working on it right away for you. All right? So just remember, we're here to help you. Let us know what you want. And as always, if you haven't done so, please like this video, subscribe to the channel, share it with a friend. It helps this channel a great deal. So I'm going to thank you for that. And it will help a bunch of other people. So have a great day. Thanks.